Chalo, in the last class, we have done up to question number 5, how to identify whether the given function is increasing, decreasing. We have done that. Okay, we'll continue that part. Now, over here, in the sixth question, what we have? Now, what is given over here? Find the intervals in which the following functions are strictly increasing or decreasing. Okay, we need to find in which intervals the given function is increasing or decreasing. Let's take the first one. If I take the first one, that is your f of x equals x square plus 2x minus 5. Now to find where the function has a horizontal line, means where the tangent is horizontal, for that what we will do, we'll put f dash x is equals to 0. So what we will do, let's differentiate this with respect to x, differentiate with respect to x. So what do you get? F dash of x equals 2x plus 2. Yeah. So your f dash of x is equals to 2 into x plus 1. Fine. And this x plus 1, whatever we have done, to find the extremities, what we will do? To find the intervals, what we will do? We'll put f dash of x is equals to 0. Therefore, what do we get? 2 into x plus 1 equals 0. So therefore, x plus 1 equals 0. And then what you get is x equals minus 1. So x equals minus 1 is the point where the tangent is horizontal, means the curve is something like this. The given function, if this is your x and y axis, the curve is at minus 1, right? If this is your minus 1, the curve is either like this or either like this. Okay, at minus 1, the tangent is horizontal. That's what we know, right? Now, how it is exactly, we don't know that. So, to find that, what we will do, therefore, the intervals are the intervals are from minus infinity to minus 1 and from minus 1 to infinity. These are the two intervals. Now let us check for which interval, whether it is increasing, decreasing. Now for the interval minus infinity to minus 1, okay, try x equals, you can take any value between minus infinity to minus 1. We'll try x equals minus 2. You can take also minus 3, minus 4, minus 5, anything is fine. Okay, if I try f of minus 2, then what is my f dash of, what is my f dash of x? F dash of x equals 2 into x plus 1. And then what is your f dash of minus 2? 2 into minus 2 plus 1, which gives you 2 into minus 1, which gives you minus 2, which is less than 0. Therefore, f of x is decreasing. Therefore, f of x is decreasing in the interval, what? Minus infinity to minus 1. Okay. Now let us check for the interval minus 1 to infinity. For the interval minus 1 to infinity, try x equals, you can try anything. Let's try x equals 0 only, because this 0 is an integer, lies between minus 1 to infinity. So try x equals 0. What is your f dash of x? That is equals to 2 into x plus 1, right? Yeah, 2 into x plus 1. So your f dash of 0 equals 2 into 0 plus 1, which gives you 2, which is greater than 0. Therefore, what I can say? Therefore, f of x is increasing in the interval minus 1 to infinity. Got it, everyone? Did you understood how it is increasing or decreasing in the interval, and how did we found the intervals? Yeah, Janani, Sneha and Abhirup, please tell me whether you have understood this or not. If you have any doubt, then please ask. Over here also, if your f of x equals x plus 1 whole cube into x minus 3 whole cube, you have to find, if I draw the graph of this, where it will be increasing, decreasing, that's what you have to find. Now to find that, what we will do, we'll do the derivative of this. F dash of x equals, you will do u into v in this. We can consider this as u and this as v. Okay, so we'll do u into v, u as it is, derivative of v, that is 3 into x minus 3 whole square, and further derivative of x minus 3, that is 1 only, so no need to write anything, plus v into, that is x minus 3 whole cube, and derivative of this will be 3 into x plus 1 whole square, further derivative of x plus 1 is 1. That's it. So what do you get? 3 into x plus 1 whole cube into x minus 3 whole square plus 3 into x minus 3 whole cube into x plus 1 whole square. If I take 3 into x plus 1 and x minus 3 everything in common, x plus 1 square as common and x minus 3 square as common, then what do you get? X plus 1, and what is left over here? Plus x minus 3 is left. Okay, so what did you get? 3 into x plus 1 whole square, x minus 3 whole square, and then x plus x is 2x, 1 minus 3 is minus 2. You can also take 2 outside, and then this will be 3 into 2, that is 6, into x plus 1 whole square, x minus 3 whole square into x minus 1. So this is what your f dash of x, right? Now again, you need to find the intervals. Now over here, we know that f dash of x is greater than 0 for any value of x when x plus 1 whole square it is. See, this will be always greater than 0. This will also be greater than 0 because they have a whole square. So for any value of x, this answers will be positive only. So the f of x will be negative only depends on this. When x minus 1 is less than 0, or when x minus 1 is a negative number, only at that point the given f dash of x is negative. That is, since f dash of x is less than 0 only if x minus 1 is less than 0, that is x is less than 1. So this is the only point where it is decreasing. Rest for all the points it is increasing. Got it? So therefore f of x is decreasing in the interval for all the values x less than 1. That means f of x is decreasing in the interval, that is minus infinity to 1, and f of x is increasing in the interval 1 to infinity. Did you guys understood this? If you have any doubt, then please ask. I'll resolve your doubts. If you have any doubt, did you got it? The f dash of x does not depend on this 2. Means the is it positive or negative? It does not depend on this 2. Why? Because they are already square. See, I'll show you the diagram also how it is exactly. I hope you guys can see the graph now. So what was your equation? F of x equals x plus 1 whole cube, right? You can write over here y equals x plus 1 bracket close, and then whole cube is there, and then in multiplication again, what was there? X minus 3 whole cube, x minus 3 whole cube. So this is what the curve is. Okay, this is what the curve we have. Now what did you get? F of x is decreasing in the interval minus infinity to minus 1. See, from minus infinity to minus 1, the given function is decreasing. But wait, it is also decreasing after minus 1. Does it meet anywhere? Yeah, over here. Oh, wait, not minus 1. It is 1, no? It is decreasing up to the interval from minus infinity to minus 1. And from 1 to infinity, it is increasing only. Can you see it? It is increasing only. The curve is increasing only. Can you see the graph? This point is that 1 comma minus 64. So at point 1, when x equals 1, only it changes. Otherwise, rest all values is decreasing and then it is increasing from minus infinity to minus, from minus infinity to 1 and then 1 to infinity. How many of you have understood this? So similarly, you have to solve the rest of the sums also. Okay, I'll solve one more sum if you want. We have done this one, this one. Okay, I think this much is sufficient. You can solve the rest of the sums. I'll take the next type of sums which we have. So now the next question. Show that is an increasing function of x throughout its domain. Now what is domain over here? It is already given x is greater than minus 1. The values of x which the function has, that's what the domain. And the values of f of x or the values of y will be the range, right? So over here the domain is x is greater than minus 1 and you have to tell that the given function, this given function is increasing throughout its domain, means throughout this domain. When x is greater than minus 1, at that time the given function is increasing only. You have to prove it. Okay, let's prove it. Over here, show that y equals log of 1 plus x minus 2x upon 2 plus x. This is what you have. Over here, the domain is x is greater than minus 1. They have given. Okay, is an increasing function of x throughout its domain. Fine. So if y is equals to this, then your dy by dx will do the dy by dx to find the intervals. Derivative of log will be 1 upon 1 plus x. Further derivative of 1 plus x will be 1 only, so no need to solve anything. Minus. To do the derivative of this, we'll do u upon v. So 2 plus x whole square. Over here 2 plus x. Derivative of 2x will be 2 minus 2x as it is. Derivative of 2 plus x will be 1. Okay. This gives you 1 upon 1 plus x minus 2 plus x whole square, and this is 4 plus 2x minus 2x. This 2x and minus 2x will get cancelled. Now what is balance? 1 upon 1 plus x minus 4 upon 2 plus x whole square. This is what is left in f dash of x. Okay. Now what we will do? This is which sum exactly? 7th sum. Okay, we got the value of dy by dx as this. Fine, this is right almost. Okay, now this is what your dy by dx. Now this has to be equated with 0, no? Right, to find now to find what they have asked, we have to find the intervals, no, first. Now to find the intervals, what we will do? We'll equate this is equals to 0. To find the intervals, put dy by dx equals 0. So therefore 1 upon 1 plus x minus 4 upon 2 plus x whole square is equals to 0. So if I take it on the right hand side, 1 upon 1 plus x equals 4 upon 2 plus x whole square. I will do the cross multiplication over here. 2 plus x whole square equals 4 into 1 plus x. Now we'll square this. 4 plus 4x plus x square equals 4 plus 4x. 4 and 4 will get cancelled. 4x and 4x will also get cancelled, and what you finally get is x square equals 0. That means x equals 0. So x equals 0 is the point where it has the increasing or decreasing function. Therefore, the intervals are from minus infinity to 0 and 0 to infinity. Fine. These are the intervals. Now, since these are the intervals, but it is given that the domain is always greater than minus 1. It is always greater than minus 1. Therefore, the intervals will not be this one. It will be from minus 1 to 0 and then 0 to infinity. Okay, for both this point. Now, this will be your intervals. Now, for the interval minus 1 to 0. Now let us take any number between -1 to 0. You can take x equals 1 by 2, -1 to 0, no? So -1 by 2 you can take. Okay, -1 by 2. Let's -1.5. So your f dash of x. What is your dy by dx? This is what your dy by dx. So let's find what is dy by dx at -1 by 2. Okay, so let's solve it. So dy by dx at x equals -1 by 2 is equals to 1 upon 1 minus 1 by 2 minus 4 upon 2 minus 1 by 2 whole square. So this gives you 1 upon 1 minus half is half only, minus 4 upon 2 minus half will be 3 by 4. Wait, 2 in LCM, 4 minus 1, that is 3 by 2 whole square. Okay, this 1 by 2 will come in the numerator, it will be 2 into 1, so finally you'll get 2 minus 4 upon 4 into, this will also get reversed, 2 upon 3 whole square whole square. So this will be 2 minus 4 into 4, that is 16 upon 9. Now if I solve this, 9 will be in LCM, 2 nines are 18 minus 16, that equals 2 by 9. Now this is greater than 0, therefore f of x is increasing. F of x is increasing in the interval -1 to 0. Okay, now let us check for the further one. For the interval 0 to infinity, try x equals, you tell me, try x equals, what I have to do? Any number, I will do it. From 0 to infinity, tell me any number, a small number. I'll do it for that. Okay, x equals 1, let's do it. X equals 1. So your f dash of x equals what? Sorry, that is your dy by dx. This time we have written dy by dx. No, both are same only. So at this time, your dy by dx equals this, and your dy by dx at x equals 1 will be 1 upon 1 plus 1 minus 4 upon 2 plus 1 whole square. So this will be 1 upon 2 minus 4 upon 3 square, that is 9. So if I do the cross multiplication now, 18 will be LCM, 9 minus 8. This gives you 1 by 18, which is again greater than 0. Therefore f of x is increasing in the interval, which interval? F of x is increasing in the interval, the other interval, that is from 0 to infinity. 0 to infinity. Therefore, what I can say? Therefore, the given function, therefore f of x is increasing throughout its domain, that is where x is greater than -1. We have checked it, no? For x is equals to, when x is greater than, the domain is x is greater than -1. We have checked for -1 to 0 and 0 to infinity. So there is no other number which is greater than this. So we have checked for all the domains, it is increasing only. Therefore, we can say the given function is increasing throughout its domain. Did you understood this, every? Okay, done with the seventh sum. Find the values of x for which is an increasing function. Over here you will try f dash of x should be greater than 0, and then find the values of x. This is also similar, you can do it in homework. Prove that is an increasing function from 0 to pi by 2. We have a similar sum like this. We'll do the other one because this is a simple one, that's why. Prove that the logarithmic function is a increasing on 0 to infinity. Over here logarithmic function is log x, and you have to prove it that from 0 to infinity it will be a increasing only. You'll get it. You try solving it. If you don't get it, then you can ask me in the next class. Okay, now I'll take the next set of problems. Yeah, the next. Prove that the function f given by is neither strictly increasing nor decreasing. Now, how you will prove that the given function is neither increasing nor decreasing? That means from minus 1 to 1, for some particular path it will be increasing, and for some particular part it will be decreasing. So we can say from minus 1 to 1 it is neither increasing nor decreasing. See, for the intervals it should be either completely increasing or it should be either completely decreasing. It cannot be increasing and decreasing. If increasing and decreasing both are there, then what we will say, it is neither increasing nor decreasing. Okay, see over here, I'll solve. This is the same sum. You please solve it in your homework. I'll solve the next problem, this 12th one. This is MCQ, but still it is lengthy question. You need to understand it properly. Which of the following functions are decreasing on the interval 0 to pi by 2? Okay, which of the function is decreasing on the interval? See, we have your f of x equals, let's try for cos x. Okay, if I try for cos x in the interval 0 to pi by 2, they have said. So what is the value of f dash of x? That is minus sin x, right? Okay, now which of the following functions are decreasing in the interval 0 to pi by 2? Now to find the intervals, put f dash of x equals 0. Okay, so your minus sin x equals 0, and you can say sin x equals 0, and the sin x is 0 at which all points? We know that sin 0 is 0, sin pi is 0, sin 2 pi is 0, sin 3 pi is 0. Therefore x can be 0 or pi or 2 pi or 3 pi and so on, right? So x can be equal to, therefore x is equals to n pi. X will be equal to n pi, where your n belongs to whole number. X will be equal to n pi, you can say, where n belongs to whole number. Now let us check for which value it is increasing or decreasing. Okay, so for 0 it is, for n pi it is. Okay, the tangent is horizontal. Fine. So they have asked from 0 to pi by 2. So for the interval 0 to pi by 2, for the interval 0 to pi by 2, your f dash of x is equals to what? Minus sin x. Try x equals any value between 0 to pi by 2. You can say pi by 6. So your f dash of pi by 6 equals minus sin pi by 6. And the value of sin pi by 6 is 1 by 2. You can say minus 1 by 2, which is less than 0. Therefore, f of x is decreasing in the interval 0 to pi by 2. Fine. But what they have said, which of the following function is decreasing from 0 to pi by 2? So option A is right. But you have to check for cos 2x, cos 3x and tan x, all of them. Because in this, maybe two answers can also be right. Let's check for cos 2x. Okay. Let's check for cos 2x. Now, when y is equals to, or you can say when your f of x is equals to cos 2x, then your f dash of x equals minus sin 2x into 2. So this will be that 2. Okay, minus sin 2x and multiplied with 2. For the derivative of 2x, that is 2. I have written them. Now, to find the intervals, what you have to do? You have to put this is equals to 0. F dash of x is equals to f dash of x equals 0. Therefore, minus 2 sin 2x equals 0. And finally, sin 2x is equals to 0. Now, if sin 2x is equals to 0, then 2x will be equal to 0 or pi by 2. Sorry, not pi by 2. Sin pi by 2 is 1. So, pi, 2 pi, 3 pi, and so on. Right? So, you can write x equals 0 or pi by 2 or 2 pi by 2 or 3 pi by 2 and so on, right? The x values will be valid for 0 to 0, pi by 2, 2 pi by 2, 3 pi by 2 and so on. So therefore the intervals are from 0 to pi by 2. What will be the intervals? 0 to pi by 2 only. Therefore the intervals are 0 to pi by 2 only. Now try x equals any value between 0 to pi by 2. You can take pi by 6. Okay. So your f dash of x equals what? Minus 2 sine 2x. Okay. Minus 2 sine 2x. So this will be f dash of pi by 6 will be equal to minus 2 sine 2 into pi by 6. Okay. This and this cancel 3. And this will be sine pi by 3 is minus 2 sine pi by 3. Sine 30 is 1 upon root 3 and no. Sine 60 is root 3 upon 2. 2 cancel. Your f, this will give me minus root 3. Fine. This is less than 0. Therefore, f of x is decreasing in the interval. The other interval is 0 to pi by 2. Before this also it was increasing or decreasing. It was it is decreasing in the interval 0 to pi by 2. Now what is asked in the question? Which of the following functions are decreasing from 0 to pi by 2? So even this question came right. Even cos 2x is right. Okay, just a minute, let me check. Yeah, it is also this for cos 2x also the answer is right. Now let us check for cos 3x. For cos 3x we'll check. Okay, again your f of x equals cos 3x. Then your f dash of x will be equal to minus 3 sine 3x. Okay, this is what your f dash of x. Now to find the intervals, put f dash of x equals 0. That is minus 3 sine 3x equals 0. That is sine 3x equals 0. Therefore, 3x will be equal to 0 or pi or 2 pi or 3 pi or so on. Therefore, x will be equal to 0, pi by 3, 2 pi by 3 and so on. Therefore, the intervals are, we know that the interval is from 0 to pi by 2, no? So over here pi by 3 is also there. That is 0 to pi by 2 means 0 to 90. But over here the tangent is horizontal at pi by 3 also. So what we will do? Therefore, the intervals are 0 to pi by 3 and pi by 3 to pi by 2. Now let us try something. Try for the interval 0 to pi by 3. Okay. Now what you will try? 0 to pi by 3. Pi by 3 means 60. So you can try x equals pi by 6. So your f dash of x equals minus 3 sine 3x. Fine. It is minus 3 sine 3x. So f dash of pi by 6 equals minus 3 sine 3 into pi by 6. This and this cancel, it will be 2. So this is equals to minus 3 sine pi by 2. The value of sine pi by 2 is 1, so it will be minus 3, which is less than 0. Therefore, f of x is decreasing in the interval, which one? In the interval 0 to pi by 3. Now let us check for the other interval. Now for the interval, for the interval, for the interval pi by 3 to pi by 2, right? Again, your f dash of x will be equal to the same thing. That is your f dash x equals minus 3 sine 3x. Yeah, your f dash x will be the same. Okay. Oh, wait. Yeah. Now try x equals. Now what we will try? From pi by 3 to pi by 2. Pi by 3 means 60 and pi by 2 means 90. So try x equals 75 degrees, and that 75 degree can be given by, you can check what is 75 degree. 45, you can say try x equals pi by 4 plus pi by 3. Pi by 4 is 45 plus pi by 6, and pi by 6 is 30. So this will be 12, 4 6 are 24, or you can also take 12, 3 pi plus 2 pi, that is 5 pi by 12. Okay, this will be your 5 pi by 12. The values, try x equals. Now, so f dash of 5 pi by 4, 5 pi by 12 equals minus 3 sine 5 into 5 pi by 12 into 3. So now what it will be? 3 fours are. So this will be minus 3 sine. This is how much? 15 pi by 4. We can also write this is equals to minus 3 sine 16 pi minus pi by 4. This equals minus 3 sine. This will be 4 pi minus pi by 4. Now there is multiple of 2 pi. This is 2 pi or 4 pi. You can directly ignore the signs. So it will be minus 3 sine minus pi by 4, which gives you, this minus will go outside since sine minus theta is minus sine theta. So it will be 3 sine pi by 4, which gives you 3 sine pi by 4 is 1 by root 2, which gives you finally is equals to 3 by root 2, which is greater than 0. Therefore, f of x is increasing in the interval Therefore, f of x is increasing in the interval which, wait, it is increasing in the interval pi by 3 to pi by 2. Therefore, f of x is neither increasing nor decreasing in the interval 0 to pi by 2. Got it? Did everyone understood what I have tried to solve over here? That it is neither increasing nor decreasing. Yeah, how many of you have understood this? Yeah, done? Acha, Abhirup is asking whether it is strictly increasing or not. We'll have to check. See, I'll solve for the last option D also, whether it is increasing or decreasing. It is an MCQ, but see the length of the sum. Okay? So do not take it lightly if you have MCQs in your exam. Okay. Now let us check whether it is increasing or decreasing. So we can say your f of x equals tan x, then f dash of x, derivative of tan x is sec square x. Now, since it is whole square, f dash of x will always be greater than 0 for any values of x. Therefore, f of x equals tan x is increasing, increasing for all values of, for x, for you can say increasing for all values of x where x belongs to real number. This is a sign for all values of x where x belongs to real number. Yeah. So even this is increasing, so it's not decreasing. So we have to tick on the number of options which are decreasing. So the only decreasing functions are this cos x and cos 2x. This is increasing, decreasing both, and this is increasing. Okay, so you cannot say this is neither increasing nor decreasing because we got to know that it is increasing and decreasing both. So everyone has understood this whole sum. Please type yes or no in the chat box, please. Did you understood this completely? Okay, Sneha, Prakash, Janani, okay, Abhirup also. Fine. Let's continue then. This 12th one is also done. The next, on which of the following intervals is the function given by is decreasing? Now see to this question also. This question is also quite tricky. A small trick is there in it. See, what you have, your f of x equals x to the power 100 plus sine x minus 1. This is what you have. Now, on which of the intervals is the given function decreasing, they have said. So let us check. So to find the increasing or decreasing, we'll do the derivative. F dash of x will be equal to 100x to the power 99 plus cos x, and that's it. Yeah, what it is? 100x to the power 99 plus cos x. Now, what they have said, they have given some options over here. From 0 to 1, from pi by 2 to pi, from 0 to pi by 2, and none of this. Okay, let's check. Now, to find the intervals, now we won't be able to find the intervals in this because to find the intervals, put f dash of x will be equal to 0. Therefore, 100x to the power 99 plus cos x will be equal to 0. But even if we take anything on that side, we won't be able to find what is x values. Okay, so we'll not work it like this. We'll do something else. So they have given some intervals, no? This question cannot be solved directly finding the intervals. Let's check for these intervals. For the interval, 0 to 1, let us check. What is try x equals 0 to 1, no? So let's say try x equals 0.5. Okay, so your f dash of 0.5 will be equal to 100 x to the power, or you can say 0.5 to the power 99 plus cos of 0.5. Now what is cos of 0.5? We don't know. Okay, this value will never be negative. This will be in decimals, but this value will never be negative. Also, cos 0.5 means it is cos of half radians. Now, half radians come in which quadrant? See, 1 radian is around 57 degrees, right? So, half radian will be in the first quadrant only. So, this will always be positive. So, this will also be positive. Since, so this and this both are positive, so the whole value will be greater than 1. You can write, since cos of half radian is always greater than 0, therefore f dash of x will always be greater than 0. Therefore, f of x is increasing in the interval. Now what they have asked, in on which interval it is decreasing, right? So in this interval it is not increasing, that's for sure. Let us check for pi by 2 to pi. Again, your f dash of x equals, your f dash of x equals this. Now for the interval pi by 2 to pi. Okay, let us check. From pi by 2 to pi, we can say this pi by 2 is 90 and pi is 90. So from pi by 2 to pi, any angle if we take, that is 135 degree, and that 135 degree can be given by that is pi by 2 plus pi by 4. So pi by 2 plus pi by 4, that will be 2 pi by 4 plus pi by 4, that is 3 pi by 4. Okay, try x equals 3 pi by 4. Try x equals 3 pi by 4. So your f dash of x will be equal to 100. X is what? 3 pi by 4 to the power 99 plus cos 3 pi by 4. Now we know that the cos value, this is 3 pi by 4. Over here the value of pi will be 3.14. Okay, so 3.14, whatever they have, and raised to 99, right? 3.14 into 3 by 4 will give you 100 into 3.14 into 3 by 4 raised to 99. Okay, plus cos, you can write this as 4 pi minus pi by 4. This equals 100. This 3.14 into 3 divided by 4. I am doing it with calculator. You can do it manually. 3.14 into 3 and then divide by 4 gives you 2.35 raised to 99 plus this is cos pi minus pi by 4, and cos pi minus theta is minus cos theta. Minus cos pi by 4, and this cos pi by 4 is 1 by root 2. So 100 into 2.355 whole raised to 99 minus 1 by root 2. Now tell me about this. This value will be positive or negative? Yeah, this value will be positive or negative? Negative. Why? Yeah, everyone. Please tell me this value will be positive or negative? Negative said by Abhirup. What about rest of the students? Yeah, Sneha and all. It will be Sneha, Sandeep, Abhirup, acha, Janani. Can you please tell whether this value will be positive or negative without solving it? We won't be solving this roll ratio 99 and all. Without solving it, can you tell whether what it will be, positive or negative? Everyone said negative. But the problem is, this value will be very huge and this value is less than 1. Even if you subtract, this value will be positive only, no? This value is very less and this value is very huge. 2.2 raised to 99 is very large value. Even 2 raised to 5, 5 if I write, that comes to 32. This is very large value and this is less than 1. This value is less than 1. So what you will get? Therefore, this is what your f dash of x, no? This is what your f dash of 3 pi by 4. Therefore, f dash of 3 pi by 4, by seeing to it, you can say it is greater than 0. Therefore, again f of x is increasing. Increasing in the interval In the interval what? Pi by 2 to pi by 2 to pi. So that means even this is not the right answer. Over here also it is not decreasing. Even if you check for 0 to pi by 2, the same way you will get, even over here also it will not increase. Over here also it will not increase. Therefore you will get, it is none of this. It is not decreasing. It is increasing value only. Got it, everyone? Yes or no? Please type in the chat box. Okay, Abhirup. Sandeep, Janani. Okay, fine. Now let's move to the next question. It's also done. For what values of a the given function is increasing on the interval 0 to 2? Let's do the 14th one now. For what values of a they have given? We have your f of x equals x square plus ax plus 1. Now for what values it is increasing, no? So let us find what is f dash of x. That is 2x plus a. Now the given value will be increasing when this value is greater than 0, right? Therefore the f of x has to be increasing, therefore 2x plus a has to be greater than 0. That means 2x has to be greater than a and x has to be greater than a by 2. That's it. The value of x should be greater than a by 2. Now after this, now you need to find for the interval this 1 to 2, no? Okay, wait, we'll not do it like this. Two x plus a has to be greater than 0. Now we know that x lies between, for the interval, we know that x lies between which point? For the interval 1 to 2, and it is closed interval. So we'll put equal sign also. So 2x plus a, 2x, if I multiply 2 on both the sides, so it will be 2 less than equals 2x less than equals 4, and plus a is there. So 2 plus a less than equals 2x plus a less than equals 4 plus a. So for this interval, this has to be greater than 0. F dash of x has to be greater than 0. So the 2x plus a lies between 2 plus a to 4 plus a. Now the given value is greater than 0 if this, the given function is increasing if this value is greater than 0. Means now both of this has to be satisfied. So if I draw if I draw the straight line, if this is your a, then this will be your 2 plus a and this will be your 4 plus a. This 2x plus a has to be greater than 2 plus a and it has to be less than 4 plus a. Right? It lies between 2x plus a. But wait. 2x plus a also has to be greater than 0, no? Wait a moment. This is what your f dash of x should be less than 2 plus a 4 plus a. Now since it has to be increasing, therefore f dash of x has to be greater than or equal to 0. So you can take both of them. 2 plus a has to be greater than 0. So should be a should be greater than minus 2. Also over here you have 4 plus a should be greater than or equal to 0. So a should be greater than minus 4. So for both this condition, if I draw a number line, minus 2 will be over here, minus 4 will be over here. A should be greater than minus 2 and a should be greater than minus 4 also. So both the conditions will get satisfied if a is greater than minus 2. Therefore, a has to be greater than minus 2. This is what the final answer for a. for what value of a the given function is increasing in the interval. Yeah, did you guys understood this or you have any doubt in this? Let I be any interval disjoint from -1 to 1. Prove that the function f given by this is increasing on I. Now what is disjoint from I? -1 to 1. That means, I'll explain, wait. I be an interval disjoint from -1 to 1. Means if -1 to 1 is the interval, disjoint from -1 to 1 means that does not include -1 to 1. Therefore the intervals of I, therefore I belongs to what? Minus infinity to 1 and 1 to infinity. Since it is disjoint from -1 to 1, no? So -1 to 1 intervals will not be there. So therefore I belongs to minus infinity to -1 and then from 1 to infinity. Okay. Now you have to prove that the function given by this is increasing on I. Means you have to prove that the given function f of x equals is increasing on both this interval. Let us check. Your f of x equals x plus 1 upon x. So your f dash of x will be equal to 1 minus 1 upon x square. Derivative of x is 1 and this is minus 1 upon x square. So finally your f dash of x will be equal to x square in the denominator and in the numerator x square minus 1. You can also write x minus 1, x plus 1, or you can write x square minus 1 upon x square. Now what you have to do? Prove that the function is increasing on I. Now we know that it will be increasing. The function will be increasing only when your f dash of x is greater than 0. So we can say x square minus 1 upon x square has to be greater than 0. Therefore, x square minus 1 has to be greater than 0. Or you can say x square has to be greater than 0. Sorry, x square has to be greater than 1. Now, x square has to be greater than 1. If I take the square root, x has to be greater than plus or minus 1. Now, x has to be greater than plus or minus 1 means x has to be greater than 1 or x has to be greater than minus 1. But it cannot be between. Wait. See, the square of any number is greater than 1 only if it is not a decimal. The square of decimal numbers are always less than 0. So x has to be greater than 1. But is it minus 1? It should be greater than minus 1. Greater than minus 1. Numbers greater than minus 1, that is not possible. Because if the number is greater than minus 1, it can be minus 0.25 also. This number is greater than minus 1, but the square of this is not greater than 1. Got it? So this values, whenever it is x square is greater than 1, at that time x will be greater than 1, not plus or minus 1. It will be only plus 1. Right? So the values of x has to be greater than 1. So 1 to infinity. It will not lie between this. Also, x can be less than minus 1. Because even if the values are less than minus 1, if you take minus 2 or minus 4 square will be greater than 1. Right? So all these values. So all this x is greater than 1 and x is less than minus 1. So both these conditions are for the increasing function. So that's what. Therefore, this is what the given, no? Therefore, I is the interval. Minus 1, less than minus 1 and greater than 1. Therefore, the given function is increasing on the interval I. Got it? Yes, everyone has understood this or not? Please type in the chat box. Now, the next question. This question is also done. Please try doing this all sums in your homework. Okay, all the sums which I have done, try doing them in your homework. Now the next sum. Okay, let me open the exercise first. Prove that the function f of x is equal to log of sin x is increasing from this and decreasing from this. Prove that this is increasing, decreasing. Prove that the function is increasing in R. The intervals in which. Okay, I'll do the 16th sum. What is given? Prove that the function f of x equals log of sin x is increasing from 0 to pi by 2. Okay, let us check. F dash of x equals 1 upon sin x. Further derivative of sin x is cos x. So your f dash of x equals cot x. Okay. Now for to find the intervals, to find the intervals, put f dash of x equals 0. Therefore, cot x equals 0. Now, cot of what is equals to 0? We know that tan 0 is 0, cot 0 is infinity, tan 90, sin 90 is 1, cos 90 is not defined. Okay, wait. Cot of what is 0? Sin 90 is 1, cos 90 is 0. 0 upon 1. Cot 90 will be 0 upon 1. 0 upon 1 is 0 only. Okay. So, x will be equal to either pi by 2 or either 3 pi by 2 or either 5 pi by 2 and so on. But it is given that you have to check only for the interval 0 to pi by 2. Now for the interval 0 to pi by 2. Okay, this comes under 1. So try x equals, try anything. Let's say try x equals pi by 4. So your f dash of x equals क्या है? What is your f dash of x? Cot x. So your f dash of pi by 4 equals cot pi by 4, and the value of cot pi by 4 is 1, which is greater than 0. Therefore, f of x is increasing in the interval 0 to pi by 2. That's it. You can write over here. Therefore, f of x is increasing in the interval 0 to pi by 2. The next thing what they have given is for the interval pi by 2 to pi. Now, for the interval pi by 2 to pi, for the interval pi by 2 to pi. Now, from pi by 2 to pi, the intervals what we got is pi by 2, 3 pi by 2, pi by 2 to pi. So even 3 pi by 2 comes under which point? 3 pi by 2. That is 3 pi by 2 is 270 degree. So that will not come. So pi by 2 to pi we can directly do. So try x equals pi by 2 to pi. Pi by 2 to pi. You can take any one. Pi by 2 to pi means between 90 and 180. So you can take 135. So you can take 3 pi by 4. Try x equals 3 pi by 4. 3 pi by 4 lies between pi by 2 to pi. Okay. So your f dash of x equals what? Cot x. So your f dash of 3 pi by 4 will be equal to cot 3 pi by 4, which gives you cot 4 pi minus pi by 4, which gives you cot pi minus pi by 4, and cot pi minus theta will be minus cot theta minus cot pi by 4, which gives you minus 1, which is less than 0. Therefore, f of x is decreasing in the interval pi by 2 to 2, and that's what is required. Therefore, f of x is decreasing in the interval f of x is decreasing in the interval pi by 2 to pi. Over here, the 19th sum, let's solve the intervals in which is increasing. I will solve this. What is given? Y is equals to x square into e raised to minus x is increasing. Okay, now for what interval it is increasing? Again, let's do the dy by dx. So your dy by dx, you will have to do u into v. X square as it is, e raised to minus x, further derivative of minus x is minus, plus e raised to minus x, derivative of x square is 2x. That's it. Now what is common in this? E raised to minus x, x is common. So what you'll get? Minus x plus 2. So what you get? E raised to minus x, x into 2 minus x. Right? This is what your dy by dx. Now this value will never be negative because that is 1 upon e raised to x, and anything to the power will never, you will never get a negative number. E to the power, because e is a positive number. E to the positive, e is already a positive number. Positive number to the power anything will always be a positive. So it does not depend on this. Now what you have to do when it is increasing? It is increasing when this dy by dx is greater than 0. That is x into 2 minus x should be greater than 0. Right? X into 2 minus x should be greater than 0. That is 2x minus x square should be greater than 0, and what you get is 2x is greater than x square. If I cancel x and x has to be greater than 0. X has to be less than 2. You can see. So the given function is increasing when x is less than 2. So when x is less than 2, also, acha, over here they have also have 0 to 2. It is less than 2. So less than 2 is over here, 0 to 2. So 0 to 2 is the answer. Got it? Because all x is also coming 0, no? We have cancelled x and x. Over here x is also coming 0. So 0 is also the interval. So you'll finally will get 0 to 2 is the interval. Got it, everyone? Clear, no? Okay. Then guys, over here we are done for today, and we have also completed this exercise. In the next class we'll be starting with the tangent and normal. Okay? Tangent and normals of the next exercise which we have in the syllabus. Okay? Chalo then, bye bye everyone. Have a good day.